Alright, I want to take a minute to kind of wrap up Chapter 8 and talk about the types of chemical reactions. But before we go to the PowerPoint and start discussing the 5 types of chemical reactions, I want to take a look at a little video. And I do this demo in class, you've seen it. Let's just take a look at it. Okay, hydrogen balloon.
The balloon contains hydrogen. When the candle touches the balloon, the hydrogen combines rapidly with the oxygen in the air. The equilibrium is far to the right. Water formation is spontaneous.
Okay, so that's just a little bit of a combustion reaction. That's actually going to be our first reaction that we talk about, is the combustion reaction. Combustion is the burning of any substance in oxygen to produce heat. So in order to have a combustion reaction, you must have oxygen. Okay? You must have oxygen for a combustion reaction. Okay? An example is CH4 gas, which is methane, which is what we find in natural gas, plus oxygen. Remember, in order to have a combustion reaction, you must have oxygen. Okay? Yields carbon dioxide and water. And you'll see this for any hydrocarbon. You may say, what's a hydrocarbon? Well, a hydrocarbon contains hydrogen and carbon. Alright, the products of combustion reactions contain oxygen, and if they're hydrocarbons, they form carbon dioxide and water. Well, what if they're not hydrocarbons? Okay, remember, hydrocarbons contain hydrogen and carbon. What if they're not hydrocarbons? Well, let's take a look at sodium, for example. If you burn sodium, you're going to end up with sodium oxide. Okay, don't forget to balance. If you have a hydrocarbon, for example, if you have C3H8, gaseous form, also known as butane, and you add oxygen to it to have a combustion, remember, you have to have oxygen in a combustion reaction, you end up with CO2 and water. Okay, CO2 and water will always be the products of hydrocarbons. Hydrocarbons. Alright, don't forget to balance. The second type of reaction is a synthesis reaction. Synthesis is when you synthesize something or you make something. Okay, you're putting something together. Alright, synthesis means the combination of two or more substances to form a compound. Alright, you only have one product. Notice AB here, you only have one product on your right side. You're taking A plus B, but you only have one product. Okay, an example would be the formation of hydrochloric acid. Hydrogen, remember it's H2 because it's diatomic, plus chlorine gas yields 2HCl gas, hydrochloric acid. Okay? Products, if they're ionic, they cancel charges. If it's ionic, it cancels charges. If it's covalent, it's kind of hard to tell what it is, but you'll see. Okay? For example, aluminum plus chlorine gas, remember chlorine gas is diatomic, aluminum plus chlorine gas, two reactants, but we can only have one product, so they're going to come together. You're going to end up with aluminum chloride. Alright, don't forget to balance this. Third type of reaction is a decomposition, and that's almost the exact opposite of synthesis. Okay? Almost the exact opposite of synthesis. You've got one reactant, one thing on your left side, breaking down into simpler substances, two or more simpler substances. Alright, AB, it's going into A and B. Alright. An example would be the decomposition of water. You're taking water, which is a single substance, then breaking it down into simpler parts, hydrogen and oxygen. This is known as electrolysis. This is what you see a lot of times in fuel efficiency gimmicks that they put on cars. They introduce hydrogen into the combustion to make it more efficient. Remember, from the video, hydrogen is very combustible. Alright, in a decomposition, if it's binary, meaning there's only two things in your reactant, then it breaks into the elements. There's only two things that it can break into. If it's not binary, if it's got more than one, if it's polyatomic, well, it's kind of hard to tell exactly what it is going to break down into. Okay, for example, potassium bromide. It's binary. There's only two of them. Binary, there's only two. We know that in a decomposition reaction, when it breaks down, it can only break into two things, potassium and bromine. Okay, remember, bromine is diatomic, so we have to have Br2, and we would have to balance that. Okay? A single replacement reaction is our fourth type of reaction. Right? It's kind of like the swapping. Okay, it's kind of like swapping. One element replaces another in a compound. A metal replaces a metal, remember, because it has to be only positive charges can replace each other. Or a non-metal replaces a non-metal. Negative replaces a negative. Okay? For example, A, right here, is going to take the place of B. And B is going to come off and be separate. Alright? A is going to take the place of B. B is going to come off. Just like in this. You got the blue ball plus the yellow and red balls yield the blue and red plus the yellow. An example of a single replacement reaction is copper taking the place of silver and silver nitrate to leave you with a silver plated metal. Okay? Just like in here. Your copper is taking the place of the silver and the silver is coming off. Alright, the products in a single replacement. If a metal is always positive and a non-metal is always negative, therefore they must take those individual places in the new compound. A metal must be the positive part and a non-metal must be the negative part. Okay? Iron plus copper sulfate. Iron right here is just going to take the place of this copper, leaving you with copper ions, copper comes off, and iron sulfate. Iron 2 sulfate to be specific. The fifth and final type of reaction is the double displacement reaction. Okay? The double displacement reaction. Ions in two compounds change partners, if you will. Okay? The cation of one compound combines with the anion of it with another. Alright, so A is going to be with D, B is going to be with C. Okay? They're going to swap partners. Remember, B and D are anions. So your cations are going to swap places. An example of this reaction is lead nitrate and potassium chromate. And I've shown you this before. Remember, I mixed the two clear colorless liquids together and we got this bright yellow liquid. Lead nitrate plus potassium chromate. Alright, notice the lead's going to be with the chromate, the potassium's going to be with the nitrate on the product side. They're just swapping places. We call it a double replacement. They're just swapping places. Alright, the products. You just switch the negative ions. For example, the negative ion on iodide is going to go with lead. The negative ion on lead nitrate is going to go with the potassium to give you this. Alright, and don't forget to balance it. And that's all I've got for the different types of chemical reactions.